Alright guys, today we're going to talk about proving that figures are similar using transformations. And that's going to be on 98 and 99, and it's not in your textbook today either. The assignment will be, but this is not. So go ahead and we're going to label 98 and 99, and we're going to get started. Hard to believe we're about at 100, and 100 is halfway through the book if you have the 200-page book. 98, 11.2, proving figures are similar. Using transformations, and that's going to be the exact same title for 99. Okay, so 99 is 11.2. Again, proving figures are similar. Using transformations. Alright, so now we're going to work on the two foldables that are included at the bottom of this video. We'll come back and glue them in a minute. Alright, let's get started on those.
Okay, we have discussed dilations. We are now going to start talking about from dilations, similar figures, and we are going to show that figures are similar using transformations, specifically a dilation. So a similarity transformation is a transformation in which the image has the same shape as the preimage. Won't be the same size, but it will be the same shape. An example of that is dilations and any of the rigid motions like translation, reflection, or rotation. Specifically dilation because we will have same shape but not same size. But it also will involve any of the others. We also need to understand that when things are similar, so two plane figures are similar if and only if one figure can be mapped. Remember, that means moved. It's been a little while since we've mapped figures onto each other. To the other. Through one or more similarity transformation. We talked about this some in the last lesson, but figures are also only similar if the corresponding angles are congruent. And if the corresponding sides are proportional. So we talked about that yesterday, or in the last lesson. So we're going to do some examples with this. A lot of this is really the same. We're going to talk about scale factor, and we're going to talk about center of dilation. We're going to talk all about all of those again. Right, once you've got that copied, we're going to look at a couple definitions, examples, not definitions. So example 1. Keep zooming out so you can see it. Example 1 says, determine whether the two figures are similar using a similarity transformation. So we're looking at the coordinate points, and I'm going to go ahead and write them down as well so we can look what happened from, you need to notice, from RST to XYZ. So this RST is the pre-image, XYZ is the image. So we're going to go ahead and list those points out, see what's going on. It does look like maybe it's a transformation. Okay. If you remember from the last lesson, we always will have, to find the scale factor, the image value divided by the pre-image value. But let's go ahead and list the points first. So we've got R, S, T. I don't need to write them all together. I've got R, S, T. So R is 0, 1. S is 1, negative 1. And T is negative 1, negative 1. Okay, and then let's look at X, Y, Z. X is 0, 3. Y is 3, negative 3. And Z is negative 3, negative 3. So our goal to see if it really is a similarity transformation is to see if we could get, by multiplying by a scale factor from each of these, by multiplying by the same numbers. And it really looks like we can. 0 times, 3, looks like what we're going to have. 0 times 0, 0 times 3 is 0. 1 times 3 is 3. 1 times 3 is 3. Negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. So this does work out. This is a similarity transformation. It says explain that. So the reason this is a similarity transformation is because we can multiply every single value by the same point, by the same number, the same scale factor. So yes, this is a similarity transformation. Since all coordinates of the pre-image can be multiplied by the same number, resulting in the image. We'll have a little less explanation in the next couple because once we get these, we're good to go. So there's your explanation. Let's look at example 2, which is kind of the same process here. Again, we're determining whether the two figures are similar using similarity transformations. By the way, this transformation is a dilation on number 1. That's a dilation. All right, let's look at example 2. Okay, so we're going from PQRS to WXYZ. So PQRS. They already list them for us. 2, 2, 2, 4, 6, 4, 6, 2. W, X, Y, Z. 5, 5. 5, 9. 12, 9, 12, 5. Okay? This one is not as easy to tell as the other one. We're trying to figure out how in the world we get from here to here. To determine that, we can talk about what we did the other day, where we take the image and divide it by the pre-image. So we could do the W values, 5 divided by 2. That's about 2.5. So we can see if that's going to work. So I took this divided by this to see if it works. So let's see if we can multiply by 2.5 on all these. I know I can here. 2 times 2.5 is 5. So let's see, 4 times 2.5. Let's figure that one out. We do have to check every single value. 4 times 2.5 is 10, not 9. So that's going to be a problem right here. So these are not, the second you find one that works out, these are not similar. So no, because they do not have the same scale factor. We're going to continue to do a couple of more in your next folder. Alright, so to determine whether they are similar or not, let's go ahead and list them. So L, M, N, O. They do go ahead and do it for us, which makes it even easier. Okay. Then let's list what we think are the image points. So G, H, J, K. We're hoping they have a scale factor in common here. Remember, we have to check every single point, or it doesn't even matter. If we don't check them all, we have to know. Okay, 1 to 2 means we multiply by 2. 2 times 2 is 4. 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. 6 times 2 is 12. 1 times 2 is 2. 6 times 2 is 12. That works out then. Yes, because they have a similar scale factor of 2, which we're not finding the scale factor just yet, technically, even though we have found it. So let's look at number 4, where we actually do have to find the scale factor to write it in coordinate notation. So example 4 says, find a sequence of similarity transformations. Guess what? We know it's similar. That maps the first figure onto the second figure, right, in coordinate notation. Sequence of transformations means I'm probably going to have a dilation, but then I'm going to have a translation, I'm going to have a reflection, I'm going to have a rotation, I'm going to have something else. It's actually always easier to start with the dilation and what we think that's going to be. We are going from A, B, D, C to E, F, H, G. To find what I need to shrink it by, I'm actually going to, and I know it's shrink because it's big to small, I'm going to find the scale factor. So let's look at this line segment. 1, 2, 3, 4. From here to here is 4 units. Here to here is 2. So from the large one to the small one, I have 4 over 2, which is a half. So I'm actually going to half this figure to start with. I'm specifically supposed to be writing this in coordinate notation, which means I have x, comma, y maps 2. I'm multiplying these by a half. I'm going to graph that new point, these new points, to determine what else I will need to do. So A is at 1, comma, 6. So that in half is 1/2, comma 3. 1, 2, 3. There is A prime. So I'll still have to move it because I've got to get it down here. B is at 5, comma 6. So half of that is 2.5. 1, 2.5, comma 3. 1, 2, 3. About right there. B prime. Okay. C is at -2, comma -2. So that in half is -1, comma -1. C prime. D is at 2, comma 2. So that in half is 1, comma 1. There's D prime. I'm going to erase this measurement because it's kind of getting in the way for now. So I'm going to graph this. And then we got to figure out what's still going on. Because I'm definitely not finished. I got to sequence transformations, so I got to keep going. All right, our goal is to get this figure, now that we have gotten a scale factor, on top of this one. So to get there, I've got to figure out how I need to shift. A is supposed to go to E. So A, how am I going to get from A to E? Let's think about our x values. I'm going to keep writing right here. My x, I'm going to need to move my point 1, 2 points. I need it to be right here. I'm going to have to move A 1, 2 points to get it where E is. So that means I'm going to do x plus 2, which means it would be right here. Now let's think about y. I now need to move it down 1, 2, 3 to get it on top of the E. So y minus 3 because I moved down. This is my sequence of transformations. That is all I have to write. The graph is just for your benefit. We're going to keep going. I think we have another one of those as well. We actually have 2 more of these. We've got more room, which is really going to help us out because we really need the room. So we've got another figure. We are now, this time, going from ABC to DEF. Looks like we're probably going to have a rotation of some sort. We don't have the coordinates written down. I'm going to write them down. It should help us out some. A, B, C. It's the smaller one, so we're probably going to get bigger. I actually don't need to write them down yet. Oh, I can. This is our x, comma, y. A, -2, -1. B, -6, -1. C, -5. No, 0, -5. Now, like we did before, we're going to go ahead and see what we think our scale factor probably is. It's always easier to use horizontal segment or something. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. Remember, it is always the image over the pre-image. 6 over 4. We can have it as a decimal or as a fraction as 1.5. That means our first step is going to be 1.5x, 1.5y. That's why it actually does help to list these out, even though we didn't on the last one. Needed some more room for that. Because we can multiply them right here. So -3, comma -1.5. Say A prime. B prime. -9, -1.5. 0, -7.5. I can graph it again if I need to. I'm going to erase the links, that makes it easier. negative 3, negative 1.5, A prime. B prime is negative 9, negative 1.5, B prime. I don't always have to graph them. It does help sometimes to visualize it. And 0, negative, I can even graph that one. Negative 5, negative 6, negative 7.5. It's down here somewhere. So if I wanted to graph it, it's kind of difficult on this one. It goes too far down. Alright. Somehow, I feel like I'm going to have to rotate it. So let's think about rotating it. If I rotate to get it this way, rotating it once will put it here. Twice looks like it would be there. So that we're thinking 180 rotation. So we could try that out. Let's try a 180 rotation. If you remember, you might have to go back and look in your notes. But a 180 rotation is, I'm going to make sure because I don't want to say it the wrong way. I'm pretty sure it's negative x, negative y, but we better check. Yes, negative x, negative y. So let's check and see what our values are. We should have 3, 1.5, 9, 1.5, 0, 7.5. Okay. Let's graph these, see what happened. 3, 1.5, 1.5. That's our A double prime, I guess. Okay. 9, 1.5. So I'm not done. Seems like a lot. Alright, double prime. I'm not finished. I know I'm not because they're not the same points yet. And 0, 7.5. 6, 7.5 is F. No, C, double prime. Alright, one last time. I've got to be done after this one because I'm getting close. Just going to have to shift it a little bit. It's always nicer when we're ready to just shift it. Okay. I'm trying to get from A double prime to D. So to get there, x-wise, I've got to go left 1, 2, 3. So that's x minus 3. And I've got to go up a half and then another 1. So 1.5. So y plus, because I'm going up, 1.5. That's going to move this one here. If I go left 1, 2, 3, and up 1.5, right there. So that one's good. B, 1, 2, 3, and up 1.5. That is perfect. So therefore, our not rigid, they're not all rigid anymore. Our similarity transformation is given by that coordinate notation that you cannot completely see. Okay. Last but not least, JKL. It's a good idea. I'm going to move it in just a second for you to try it on your own to make sure you can understand and get these transformations. We are again going big to small, JKL to PQR. We're going to list out JKL and see what our scale factor should be. So we'll start with x, comma, y. 2, we don't know yet. J, 0, 1. K, 1, 2. L, 3, 1. Alright, let's go ahead and look at this piece here. Looks like this is 3 units. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. We're getting larger. It's 9 divided by 3, which is 3. So, 3x, comma 3y. So J prime is 0, 3. K prime is 3, 6. L prime is 9, 3. We're going to graph it again. Erase these links. They're hard to see after a while. We get a little confused because there's a whole lot going on. 0, 3. J prime. 3, 6, K prime. 9, 3, L prime. Kind of looks the same, it's just a little larger, as you know, same size, same shape, different size. So we're definitely not done, because we got to move something around. Let's think about rotate or reflect first. Not sure if it's a reflect. Ooh, maybe. That looked like a reflection right here. This would come here, that would come there, that would go there. That's what it looks like. A reflection across this line, which is y equals x. The rule for y equals x, the easiest way I always remember, it's just y comma x. So we're just going to flip our y and our x's. We hope that this works and it's exactly what we want, but we're not sure yet, so we're not going to put our letters just yet. 6, 3, 3, 9. So we're just flipping them. Let's check. 3, 0. 1, 2, 3, 0. That is P. 6, 3. 6, 1, 2, 3. Q. 3, 9. 3, 9 is R. We are finished because they match. So our sequence of similarity transformations is given there. These can have more than one answer, so just because you might have done it by yourself and gotten a different answer, as long you might have 4, you might have 5, as long as the end is exactly where the figure is, that is fine.
Alright, now that we are finished with those, we're going to glue in the first one on page 98, the first one being the one where we define similarity transformations and all that. So we're going to glue that in on 98. Alright, and then the other one we'll glue in on 99. So this is example 3, the one we finished. There it goes on 99. Let's glue that in, and then you'll be able to start the assignment. And if you have any questions while you're in the assignment, make sure you ask. That's why I'm here. Ask for help. There we go. That's on 99. And go ahead and start the assignment. It's on Google Classroom.